as you know, AppNexus is coming up on our 10th year anniversary. We've done 4 of these optimizes, and it's useful, I think, at these moments to think back to really the founding principles of why we started AppNexus. And from day one, we wanted to build a platform, a company that could help build innovation. If you look at our very first fundraising deck, which I think First Round Capital posted on the web, it actually leaves white space. We said we're going to build this part of the stack, and we're going to leave the rest for our clients to innovate. And that's always been the idea behind this business, is that it's a big internet. There's incredible ways that you can create differentiation and value. And the best thing we can do is to build a platform for innovation, specifically in advertising. And we think that with a core value set and a mission about creating a better internet, if we can help you foster that with less effort, with more technical innovation, we can jointly achieve that mission of making the internet better. And I'll remind you all of the basic virtuous cycle here. If we help marketers get better outcomes in digital, then they'll spend more money on publishers who will produce more content, which will drive more people to the internet to buy products from those marketers. So each part of that cycle benefits from technology and from innovation. So that's why we're here. Now, one of my obsessions for over a decade now has been how can we allow prediction, optimization, machine learning, artificial intelligence, your choice, to become a core part of the advertising ecosystem? How can we let these predictive algorithms make better decisions about which ads to show to which people at the right time without requiring an extraordinary amount of not just technical effort, but technical systems? How can you do this in a way that's cost effective for an organization that wants to inject value into the ecosystem without having to hire a bunch of programmers and buy a bunch of servers and do all of these things that separate the value creation from the technical implementation? 2 years ago, we announced here at Optimize the AppNexus Programmable Bidder. And I want to talk quickly about the history of APB since we launched it. So APB is AppNexus Programmable Bidder. So we started off years and years ago at AppNexus with just a very simple API-based DSP product. The first version, for those of you who've been around a really long time, was called Display Words. It's now called AppNexus Console. It's always had powerful APIs. But if you look at this graph, I want to characterize where I think we've come as a company and as an ecosystem around allowing innovation. And the term I'll use for this is expressiveness. I'm stealing this from our data science team. How expressive is an algorithm? How complex of a underlying data set can we express in the bidder for real-time decisioning? The more expressiveness, in theory, the better we can map our models to the data, the more accurate our prediction, the more money we make for the marketer, for the publisher, the more relevant the ads are for the consumer if we do our job. So we want to maximize expressiveness, and of course we want to minimize technical effort. So if you go back to 2010, we really had a couple of options. You could build your own bidder, which takes an extraordinary amount of technical effort and is very expressive. You can make it do anything you want. However, it's still a huge amount of effort. We've estimated this before. A team of 10 or 15 people seems reasonable. You've got to buy a ton of servers. You've got to deal with QPS. You've got to build a UI, reporting, integrate with a bunch of supply partners. There's a whole bunch of things you have to do to build a bidder. And if you want one that works really well, you still have to hire data scientists, and you still have to think about those algorithms. Now, we also had these APIs I mentioned. Now, APIs are a very powerful way to create campaigns in the AppNexus platform. So instead of going and building your own bidder, you could write a script that would create campaigns breaking out by segment, by inventory, by geo, by all these different variables. And it's technically very easy. The script runs, the campaigns get created, but it's very hard to express a complex algorithm through breaking out a few thousand campaigns. This was a start, but there's still a big gap here between the expressiveness of your own bidder and what we can do through these APIs. So a year later or so, we invented the idea of a real-time data provider. We would, at the time we received an ad request, send it out to a server to a piece of technology in the cloud or hosted in our cloud, and you could come back with a value. That could be an absolute value, like bid $3, or it could be a modifier. Say, take the current prediction from AppNexus and multiply it by this number. Now that brings in almost infinite expressiveness again, because you can put all kinds of interesting data in your real-time data provider. And so many of the most, innovative companies in the space, many of you have built these real-time data providers to start to influence the bidding on our platform. Other companies out in the ecosystem have just launched this recently, and they call this bring your own bidder, or bring your own bid. We've been doing this for 7 years, and it's been a very powerful part of the ecosystem. So if you model this, not quite as expressive as your own bidder, but it's actually pretty hard. We give you about 10 milliseconds to respond to these real-time data provider requests, and it turns out that managing the QPS is hard. Keeping up with the volume, you're going to get 1 million requests a second if you look at this across all our data centers. You have geographic distribution issues. You have to still go back and set things up in the AppNexus system. So this isn't a panacea, while it is still easier. And one thing I'll point out here is that we see the green dot above the blue dot, meaning this is a higher ROI decision than if you wanted to build your own bidder. And that's why so many companies gravitated to this solution. But we thought we could do better. We thought we could expand the ROI here. And so 18 months ago or 24 months ago, we rolled out Bonsai. Now, Bonsai is our decision tree-based API system where you can push a decision tree into AppNexus console, and we'll take care of all the technical execution for you. We'll run your decision tree in real time, and that's it. So very easy from a technical perspective, and fairly expressive. Definitely more expressive than APIs, but possibly not as expressive as building your own real-time data provider or a bidder. Just as a reminder, decision trees, you can see how it works here. You can put condition statements at the top, go down to the leaves, and in these leaves you can put a value. So if we're in New York, if it's Thursday, then let's bid $4. And of course, these could get very complex. And if you look on the right here, you can see all the available features. So you can plug in any of these variables with complex conditional logic and build very, very complex algorithms. So how expressive is a decision tree is a fair question. It's as expressive as the number of conditions and the number of nodes that you put together. Today, we allow about 3 or 4 megabytes of data in a decision tree, which corresponds to, let's say, 10,000 nodes. So it's fairly expressive, definitely more expressive than a few hundred campaigns. And we believe that since we announced this 2 years ago, we've had very good results. We've had 45 clients in the alpha program. We've seen $38 million spent using bonsai trees. 92,000 custom models have been uploaded by our clients and partners over the past 2 years. So by most people's standards, an incredible success that we're very proud of. But you'll notice that it says alpha. We've never felt like this could achieve our business goal, meaning that we could build something as expressive as your own bidder with significantly less technical effort. But to see how expressive it was, to see how well we could do using our own algorithm, we did something called dog fooding, meaning we tried to eat our own dog food. What would happen if we used our own system to build our algorithms for the platform? Now, if you want to serve dog food, you need a data scientist. Good. So, Abe Greenstein, who is our head of the buy-side data science team, volunteered, or was voluntold, to take on this project, to upgrade our optimization system using Bonsai. So Abe, tell them how you did it.
Hi. Hi, my name is Abe, Director of Buy-Side Data Science at AppNexus, and I like math and dog food. So at the time, Brian was insisting I eat the dog food. My team was working on a problem where we try to model the relationship, and we have existing models to do this now, but we were trying to improve our models to model the relationship between advertiser frequency, which is the number of times a user has seen an ad from a given advertiser, and recency, which is how long or how much time has elapsed since the user last saw an ad. We call these models our cadence models, because we've seen different advertisers have a different cadence where if you show them ads at the right almost beat, people are more likely to respond. So before getting into what we did, because we're data science, we look at data, then we do science. I want to show you some of the data for different advertisers. So here we have two surface plots. The x-axis is advertiser frequency. The y-axis is advertiser recency. And the color denotes CTR. Dark is good. Purple means people are clicking on your ads. Light blue means you are being ignored, which we don't want. And what's interesting to me, if I look at these two different data sets, is they express very different trends. So over here, this is an interesting one because we have this hot spot here, which really ranges from about a frequency of 5 to 25 and a recency of about 2.5 and 3 hours. So this advertiser is able to really wear down the user. They show them an ad, wait 3 hours. Show them an ad, wait 3 hours. And then after some point in time, they either break down or some sort of inception happens and the user decides to click on the ad. Whereas this advertiser has a simpler trend, right? It doesn't seem to be a strong function of recency. It's all about lifetime frequency. After about a frequency of 7 or 8, the user either saturates, or if they were going to click, they would have clicked. So the challenge for us is how do we use models that are expressive enough to capture both of these trends with the same algorithms? Now, how many people here are familiar with or have used regression trees? All right, I got 2. Now, you guys don't need to know much. For those who were at Optimize last year, I find these things oddly exciting. But the biggest thing to know about regression trees are they are non-parametric, meaning they make no assumptions about the underlying data. It's a pure data mining technique. There's no heuristics involved. There's no expert opinion. It's just mine the data, get the model. What's also good to know is they are a good fit for bonsai. If I look at my graphics here, over here, this is kind of what a bonsai tree looks like. You don't upload pictures, but you upload conditional statements. And here is the model expressed in a graphical form, where, all right, is frequency less than 20? Yes. I'm on this side of the plot. Is recency greater than a day, or 1,440 minutes? I'm up here, return that value. Now, what's very nice is if we have sufficient data, we're able to mine it and replicate really any trend that expresses itself in the data. So after many sleepless nights, much backtesting, analysis, et cetera, we said, Brian, we're ready. We want to do this. We think we can do this and get it to work, but there's a problem. We treat our cadence algorithms separately from our general click prediction. For those of you not familiar, we have a general click prediction model, a separate cadence model, which is also in itself part of a prediction, and we combine them by multiplying and normalizing for one final wonderful prediction. Now, the issue with Bonsai at the time, or rather APB at the time, was that we could only upload and override whatever valuation was there, when in fact we wanted to take part of the old valuation and then modify it with our new cadence model. So I said, Brian, we can't do it, and he told me to talk to Uri.
Hello. Hi guys, my name is Uri, and I lead the technical services team here at AppNexus. And for the past 2 years or so, I've been partnering with a lot of the folks in the audience today to test out the pipes on the AppNexus Programmable Bidder product, and Bonsai specifically. And we're going to do just a real quick review of how it works. Basically, when you are going to integrate with us using Bonsai, you have 2 options for the method of expressing your expected value. Basically, you can upload a bid pricing model. In the bid pricing model, you are going to completely replace the expected value that's fed into our bidder. So that basically becomes your bid in our V7 optimization setup. Your other option is to upload a bid modifier model. In a bid modifier bonsai model, basically the leaf node of the tree is going to be a multiplier, which gets multiplied out by the expected value that the console bidder comes up with. So it's a way to use our bidder to determine the base bid and then modify it up or down based on your insights or data. And we got quite a ways, as Brian talks about in the beginning. I think that actually let you do some things you've never been able to do before, integrating APB on top of our bidder. But we heard some feedback from clients that was somewhat similar to the problem that Abe just expressed. Basically, clients were wondering, is it possible to integrate with you in a more complex manner? What if, for instance, we would like to rely on AppNexus's awesome click prediction, as well as AppNexus's cadence models, but where we have insights and data, so for instance, where we want to estimate the probability of a conversion, or maybe the expected value of a conversion, we want to layer in our own model so it slots right there. Great. So here's the solution that the product team came up with: conditional component models. The basic idea behind conditional component models is that we are going to explode out the expected value bid formula into its constituent parts. So in this case, if you look at the orange versus blue text, you're going to rely on AppNexus to provide the orange models. So the probability of a click given an impression, as well as the cadence models that Abe was just talking about. But where you have data and insights, you're going to layer in your own probability of a conversion given a click, or your own expected value for a conversion.
Right. So what's cool about this is now we've made it easier to build because you don't have to build the whole model, but it's also more expressive, meaning you get to leverage all of Abe's hard work instead of your own. So your effort gets you more technical value, more expressiveness, which I think is great. So Abe, did it work?
Yes, of course.
Can you flip the slide? Here.
So clearly it's up and to the right, meaning it worked.
Get the picture.
Up and to the right. In all seriousness, this is some anonymized data for a member that we tested with on their entire seat. And when we released here, we saw a huge uptick in clicks. CPCs dropped too, but the increase in CTRs is what I found more exciting than the drop in CPCs, because we essentially created more value. I mean, if we could create more clicks and more engagement, then good things happen.
Yep. So fantastic. It worked. And so as with everything at AppNexus, once we're successful, I want more. And so I said, great, Abe, you made one component better. Now, can you make the generalized click model better? We've got Bonsai, you've proved you can do it, and you don't like to sleep, so let's make it happen.
Well, Brian's a tough crowd. So, again, new problem, more data, more science. So I just wanted to show you some of the data. This is a little shot of my terminal, and it's just a tiny piece of the data. I couldn't get more data to fit on the screen. But the important thing here is how wide the data set is. When we think of those cadence models and how much expressiveness we wanted to get out of the data, that involved only 2 predictors. I mean, here, every column is a new predictor. There's a lot of relationships to capture. So we started off with using regression trees, and the bidder team was not happy. So we made these giant trees, and they took up these giant files, giant memory footprints, timeouts. They were not happy. So we had to start revisiting new techniques to use. So what are some different data mining machine learning techniques we could use to get the most out of this data? After doing some research and backtesting and prototyping, we really locked in on logistic regression for click prediction for a few reasons. First of all, it's both expressive and scalable, meaning that if I want a very expressive tree model, it's this giant file. For a logistic regression model, it's a set of coefficients. It executes fast. It's just a dot product and an explanation to score it. On top of it, we have added benefits of richer literature for training the models in a distributed fashion, embedded feature selection, and it also lets us automate the trade-offs between model expressiveness and data sufficiency. So we said, Brian, we love APB. We want to program the bidder. But there's a problem. We actually want a regression model, or a logistic regression model in there, not to be confused with the tree. So once again, he told me to talk to Uri.
Possibly great for the product team because we were actually hearing a lot of the same feedback, again, that our data science team was giving us from you, our clients. What we're seeing is basically a lot of folks who were testing with APB and Bonsai and Alpha were already using logistic regression models on their own hardware. And the process was basically model data from the log level data feed, turn it into a logistic regression model, and then take the output and attempt to hammer it into a Bonsai tree. And one of the most common pieces of feedback we were getting when a client attempted to turn a logistic regression into a Bonsai model was, we are hitting our 3 megabyte limit. On top of that, we feel that in that translation layer, it's probable that we're losing something important, and we're seeing some overfitting issues when turning logistic regression into Bonsai. So we said, great, let's go ahead and build an API that directly addresses the logistic regression issue and allows you to upload logistic regression models directly onto our API. Again, the idea is kind of simple. You will serialize your model into JSON, upload it using our REST API, no Bonsai involved in this step. We will allow you to put the coefficients of your model into lookup tables, which will allow you to dynamically alter the coefficients without having to re-upload the entire model every time you want to make a change. In addition, we're going to provide hash tables, which will allow you to reduce dimensionality on those features. And that has the added benefit of if our bidder provides a value that you are not prepared to take, that you didn't put into your model, it's automatically handled in the hash table. And then finally, we will use what we're calling the Genie engine to in real time, evaluate the results of your model and provide it back to our bidder at the time of the bid. And basically, as we've been talking a lot about dogfooding, Abe's team has gone out and built the beginnings of our click prediction on top of this logistic regression system. And if you're interested, we have a breakout session with Tian, Yana, Noah, and Ankit, where they're going to dive into the story of how that has gone so far. Basically, pick up the story from where we're leaving off here. But I will call Abe back out to talk a little bit about the results.
Yeah, just so some quick preliminary results. We weren't setting out to beat anything yet. We just wanted to start getting parity with our current optimization, and we took a few line items from a member and did some testing, and the results have been pretty encouraging. Saw a 10% drop in CPC, delivery was maintained, so we're pretty excited about it. Moreover, we really haven't begun to do it amazing yet. There's so much more ground to explore, so much more predictors to throw in, et cetera, et cetera.
So we're early on the path of actually using logistic regression. One thing that I think is exciting is that if you look at some of the data science research, some of the papers that I would consider fairly seminal in our space, there's a great paper by Yahoo Research and some others that basically describes how they got the best outcomes. And it really boils down to building complex logistic regression models where they combine features and they do feature hashing. In other words, we can take the state-of-the-art research that is being used by some of the most sophisticated modelers out there and plug it into our platform with very little technical effort required. Meaning your data science teams, or you, if you're a data scientist, can take the output of your logistic regression model, hit some fairly simple APIs, create the model, structure it, upload your coefficients, which you can upload again and again and again as your model learns and changes. And we take care of all the technical complexity of running that for you. Meaning, we'll figure out how to store that 1632 megabyte file in memory. We'll take care of distributing it globally. We'll deal with budgeting. We'll deal with reporting. We'll deal with all the complexity. So from your perspective, this looks like using AWS or Azure, where you can literally push all of your intelligence into the cloud. We look like a cloud here, and we'll make it work for you. I think the Lambda interface, if you will, where you upload some code and AWS takes care of your real-time request process is something like this. We get all of these inbound bid requests, we apply your logic, and we'll spit you back the outcomes without you having to build a server. So I believe this actually achieves our original goal, which was to create something that was as expressive as a bidder you could build yourself. So if you were the state of the art, you could do your algorithm in our platform with a minimum of technical effort. I want to talk for a second, though, about the implications of combining logistic regression with conditional component models and the data science that AppNexus does every day. One thing we didn't talk about today, but that we could have, is engineered features. One advantage that we have as AppNexus is that we physically deliver about 11 billion ads every day. And we can mine parts of that data for platform-wide use. For instance, viewability. We know, not just in a per site level or per app level, but in a per placement level by time of day, by device type, by browser, by all these different dimensions, how likely the user is to view an ad. So what's the viewability rate of this given ad spot? And we can do that with more accuracy, I think, than anybody else because of our breadth and because, of course, we've had our data science team build complex models to figure out exactly which ads are most likely to be viewed. Now that becomes a variable in our prediction. So when you upload your bonsai model or your logistic regression model, that becomes a feature of your model. Put differently, we're making your data set wider. And our goal is to give you more and more features that you can plug into your model that we've already done the hard work for. So even if you built your own bidder, you wouldn't have our viewability signal. You wouldn't have some of our click signals. You wouldn't have video complete signals. You wouldn't have pricing signals. So we can actually make our environment more robust than what a bidder would be able to do on its own. So we had a debate just before this about whether that green dot should be even higher, because we think we're now more expressive and creating more value than a standalone bidder. So I'm very, very excited about this. I think over the next few months, we'll start to have even more firm results from our team about this. We've built a ton of systems that make this possible. This is very technically difficult because of the scale and processing speed we're talking about. And I think the teams will be talking in some of the breakouts about some of the technical challenges we've found doing this. Now, you might say, well, if Abe's doing all this great data science, what's left for me to do? Well, the truth is that Abe's really only focusing on, and his team are focusing on, a few predictions. So likelihood of view, likelihood of a complete, likelihood of a click. But there's still a ton of really interesting KPIs that we're not going to focus on. And we believe where the ecosystem will innovate is what are more interesting features to plug in? What are some of the other KPIs? Incrementality, return on ad spend, multi-touch models. There's all these different things that marketers want that you can build on top of our efforts to create. And we've seen this since the beginning of AppNexus, that you will out-innovate us. I'm not standing up here telling you that we're the most innovative company in this room. What I am telling you is that our innovation is built to give you a platform on which you can innovate where you create the most value. You don't have to innovate on how do you stand up a whole bunch of servers without a whole lot of cost. You don't have to worry about that, or about budgeting, or pacing, or UIs, or reporting, or all the things you get out of the box. Your job in the APB world is to create powerful algorithms that get better outcomes for your customers. So, as I mentioned, we'll have some breakout sessions. We'll have Q&A in just a second, so if you have questions for us, we can spend a few minutes on that. Where's the mic? Oh, we'll have runners. Awesome. So I suggest that people very far apart ask questions so that the runners have to run a long way. We also do have these breakout sessions. So Jeremy will be talking about the lookup table and arithmetic virtual machine, which basically is how the heck do you run these massive complex models at real time at the kind of volume we operate at? So how do you generalize this and make it possible? We'll also have, as Uri mentioned, the data science team and some of the op tech folks talking about how we actually build the logistic regression models at great scale. So very wide and very big data sets. And finally, just outside, there's an Ask an APB Expert booth. So I think this is the kind of thing where if you stump them, you get a prize. I'm not completely sure. But please do participate. We'd love to answer your questions, and we'd love to collaborate. We're still learning a lot about what this can do, and super excited about the opportunity to continue to power innovation. And with that, thank you. I will open up for Q&A.